5, part A. Let f be the function defined by f of x equals 3 over 2x squared minus 7x plus 5. It asks us to find the slope of the line tangent to the graph of f at x equals 3. So it's asking us to find a slope, which means it's asking us to find the derivative, and we want to find it at x equals 3. So to find this derivative, you could either use the quotient rule or the chain rule. If you're going to use the chain rule, you would bring that 2x squared minus 7x plus 5 up to the numerator and put it to the negative 1 power. So I am going to use the chain rule, but if you use the quotient rule, you're going to get the same answer as me. So what I'm going to do on this one is I'm going to bump my negative 3 up front. I'm going to get negative 3, 2x squared minus 7x plus 5 to the negative 2 times the derivative of the inside. So I'm going to get times 4x minus 7. So if I rewrite that, my derivative is going to be negative 3 4x minus 7 over 2x squared minus 7x plus 5 squared. Okay, it asked me to find the derivative at 3. So I'm going to now plug in 3. So I'm going to get negative 3, 4 times 3 minus 7 over 2 times 3 squared minus 7 times 3 plus 5 squared. And then I'm going to go ahead and work that out. If I work that out, I end up getting negative 15/4. All right, if you left your answer like this, they will give you full points. So if you think you're going to make a mistake somewhere in between, don't work it all the way out. So we are going to get 2 points for that problem. I'm going to get 1 point for correctly finding the derivative, and then 1 point for getting the correct answer for that part. So far, okay. All right, part B asks me to find the x-coordinate of each critical point of f, so that's number 1. In the interval 1 to 2.5, notice that 1 and 2.5 are not included, and then classify each critical point as the location of a relative minimum, maximum, or neither. Justify your answer. So that's going to be our second thing. So we'll do both of those. Okay, to get the first one, I'm going to rewrite the derivative here, so I've got something to look at for that. All right, 2x squared minus 7x plus 5 squared. Okay, to find critical numbers, please remember we're going to set the numerator and the denominator equal to 0. If you set the numerator equal to 0, you're going to get a critical value of 7/4. If you set the denominator equal to 0, first of all, I'm just going to square root both sides, so I'm just going to get 2x squared minus 7x plus 5 equals 0. This will factor. It will factor as 2x minus 5, x minus 1. And I'll still set that equal to 0 using the zero product property. I'm going to get x equals 5 halves and x equals 1. So those are all my critical values. However, if you look at 1 and 2.5, since there's no equal signs on this interval, those are not included. So all of that work, that is not a critical number. So this x equals 7/4 is the only critical point. Okay, so then we did that. So that was the first part, and then the second part was for each critical point, decide if it's a minimum, maximum, or neither. So now I'm going to go ahead and make an f prime chart, and I only need to put 7/4 on it. So if I pick something before 7/4, but it needs to be in this interval, let's see, I'm going to pick, maybe 6/4. So if I pick 6/4 and I put it into this equation right here, I'm going to come up with a positive value. And if I pick something after it, but it has to be between 2 and 2.5, let's say I pick 2. If I put 2 in here, I'm going to get a negative value. So if I'm looking at is there a maximum, minimum, or neither there is going to be a relative maximum at x equals 7/4, and that will be because f prime changes from positive to negative. All right, I am going to get 2 points. I'm going to get 1 point for finding that x coordinate, so I got 1 point for getting that x equals 7/4, and then I get 1 point for saying that it is a relative maximum and y. All right, for part number 5, part C, using the identity that 3 over 2x squared minus 7x plus 5 equals 2 over 2x minus 5 minus 1 over x minus 1, evaluate this integral, or show that the integral diverges. Okay, they kind of nicely helped me out here because they're getting it set up as a partial fractions problem for me. So really they're wanting me to find this answer. So it definitely is a partial fractions problem. Okay, before we do that though, we've got this infinity going on, so I need to change this problem to involve a limit. So it's going to be the limit as w approaches infinity of 5 to the w, 2 over 2x minus 5 minus 1 over x minus 1 dx. Okay, actually they did all the partial fractions for us, so we don't even need to do partial fractions. We just have a minus sign here. I can take the integral of each one separately. So if I'm taking the integral, so I'm just going to have 2 over 2x minus 5 dx minus 1 over x minus 1 dx. Boom. Boom. I'm going to make sure that it's still a limit. I'm just going to try to keep carrying that along with me. Okay, here, if I did a u substitution, u would equal 2x minus 5. Du is equal to 2, which I have. So if I rewrote that problem, it's actually just a du over u problem. So this part is going to be ln. So I'm going to have the limit as w approaches infinity still. I'm totally going to run out of room on this problem. But anyway, okay, so we're going to get ln of 2x minus 5 minus, this one if I did a u substitution, u equals x minus 1, du equals 1, yep, we got it, it's du over u. The limit of du over u is ln once again. Okay, and then we are evaluating that at 5 and w, but before I do that, I am going to put those together because it's going to make it easier for me to evaluate. So this is still going to be the limit as w approaches infinity of the ln of 2x minus 5 over x minus 1, and I'm still evaluating it at w and 5. So if I plug in w, still keep that word limit hanging on just in case they really, really want it. ln of 2w minus 5 over w minus 1 minus, if I plug in 5, I'm going to get the ln of, technically I really should have those absolute values there still, 5 over 4. And I dropped the absolute values on here because 5/4 is already a positive number, so I'm all good with that. So now if I find the limit as w approaches infinity, we can go inside of here, and if I find the limit as w approaches infinity, I'm going to get infinity over infinity, which means I can use L'Hopital's rule. So if I use L'Hopital's rule, the derivative of the numerator is 2, the derivative of the denominator is 1, so this limit is going to be 2. So if I drop the word limit, my answer is going to be the ln of 2 minus the ln of 5/4. That is going to be my answer. I think they're pretty unpicky about what I did in between here. That's why I didn't show a lot of work. So from here, they're kind of, at least when I looked at the answer key, they went straight from here to here without having to show any work. So I'm not going to either. So we would get, let's see, how many points was this one? We'd get 3 points for this one. If we properly took the antiderivative, which could be here or here, either one, you would get a point. For making sure that it was a limit expression, you got a point. And then if you got this right answer right here, you got your 3rd point. Okay, for part D, determine whether that series converges or diverges and state the conditions of the test used for determining convergence or divergence. So we did 1 and 2. So 1, if we want to determine whether this converges or diverges, we have all sorts of, it was basically the same problem that we were doing in all the other parts. If I want to know if it converges or diverges, we've got all sorts of tests. One of the tests is the integral test though, so I'm actually going to refer to what we did in the last problem. We found an answer using the integral test, so I'm just going to say according to the integral test, since we found that the integral from 5 to infinity of 3 over 2n squared minus 7n plus 5, we found out that that was equal to, we found out that it, since this converged, we could get an answer, we could put an answer not, converges, then the series also converges. Okay, then, so that was worth a point. All right, the next part, we're not really used to writing this. It says we have to state the conditions of the test. Well, in order to use the integral test, there are actually 3 things that we have to say about it. The 3 things that we have to say about it is that the function f that we were talking about, it had to be continuous, which is a continuous function, so the f is continuous. If we use the integral test, it also has to be decreasing, and it also has to be positive. So we'd get 1 point for that. So we might want to look over the conditions of using that test before we get into our major stuff. So those are all your points for number 5.